Hi all, I am Rihanna MS, Assistant Professor, Department of Civil Engineering, SNIT Adoor. Here we are studying the subject CE362 Ground Improvement Techniques for the 6th semester Civil Engineering as per APJ KTU syllabus. In this subject, we are studying the 6th module which deals with the hydraulic modification of soil, that is drainage and dewatering methods. In this module, we have already studied about what is dewatering, what is the importance of dewatering, what is the purpose of dewatering, what are the advantages and disadvantages of dewatering, what is construction dewatering, which are the different methods employed for dewatering, etc. We have already studied in detail about the various methods of dewatering such as open sumps and ditches, well point systems, deep well drainage, vacuum dewatering, electro-hose, ejector wells, French drains, etc. And the working procedure of the individual methods is studied in the previous sessions. Today, our topic of discussion is the design of dewatering systems. Design of dewatering systems. A complete dewatering system should be capable of lowering the groundwater table up to a particular required depth. It should intercept seepage into the excavation, and at the same time it should remove the surface water which would affect the operation of the dewatering system or construction. So, the design of a dewatering system depends on many factors. The design of a dewatering system requires the determination of the number, size, spacing and penetration of well or well points and the rate at which the water must be removed from the pervious strata to achieve the required groundwater lowering or pressure relief. The size and capacity of pumps and collectors also depend on the required discharge and drawdown. The selection of an appropriate dewatering system and its design depends on factors such as geology, soil and water table conditions at the site, the magnitude of the excavation, surface water runoff and the construction requirements. The important steps in designing a dewatering system is presented below. First one, subsoil investigation. Second one, source and water table details. Third one, distance of well points from the source of seepage. Fourth one, effective well radius, which is RU, and the discharge computations. So, these are the 5 steps involved in the design of a dewatering system. First step is subsoil investigation. Second step is the identification of sources and collection of water table details. Third step, distance of well points from the source of seepage is fixed, and then the effective well radius RU is calculated, and after that the discharge is computed. First step, subsoil investigation. Utmost importance should be given to know the characteristics of soils adjacent and beneath the excavation. The depth and spacing of borings have to be properly planned to ascertain the thickness of stratified soils and soils with significant variation. Samples should be taken at frequent intervals in order to identify the soil type, the permeability characteristics of the soil, and the layers of the soil or any other impervious material such as clay. The position of water table and substratum pressure should be carefully recorded. So, the characteristics of the soil adjacent and the beneath the excavation should be investigated well. The grain size distribution and permeability are the 2 parameters that should be determined during subsoil investigation. The Indian standard recommends a field pumping test for subsoil investigation. The second step is source and water table details. Source of seepage and knowledge of the water table and any substratum pressure at a site are most important factors to be considered while designing a dewatering system. The source of seepage depends on the geological features of the area, nearby streams of water bodies and amount of drawdown. A flow may be from an aquifer being drained the distance to which is known as the radius of influence. It can be estimated from the drawdown curve established from a field pumping test. The third step is the calculation of distance of well points from the source of seepage. If the radius of influence R is large compared to the radius of the well, only an approximate estimation of R may be sufficient, since the discharge is not much sensitive to the value of R. An accurate estimation of the distance L from the well to the river should be made for a particular dewatering system, since the discharge is inversely proportional to the value of the L. Based on the field condition, the value of R or L should be ascertained. In the next step, that is the determination of effective well radius RU. It is effective well radius, not effective wall radius. By mistake it is specified as wall, but it is effective well. So it is effective well radius RU. The effective well radius is decided based on the installation of the wells with or without filter. If a well is installed without gravel or a sand filter, the effective radius can be taken as 1/2 the diameter of the well screen. If a filter is used, the well radius is taken as 1/2 the outside diameter of the filter. It is effective well radius. By mistake I have put it as effective wall radius, so correct it as effective well radius. Next step is discharge computation. The discharge Q of the well is calculated using the formula Q is equal to pi k into h square minus h square divided by 2.3 log 10 to the base R by R. This equation is already studied in well hydraulics in the previous semester in water resource engineering. So the discharge of the well is calculated by using the formula pi k into h square minus h square divided by 2.3 log 10 to the base R by R, where Q is the discharge, K is the permeability, H is the depth of the strata, small h is the height of water in the well, small r is the radius of well, and capital R is the radius of influence. So finally we can estimate the discharge by using this particular formula. Hoping that you have understood the design steps and design procedure for designing a dewatering system. So it is important study the procedure well. Refer textbooks for further details. So okay, thank you. Stay safe. Have a nice day.